Hello everyone, today I'm going to explain AWS VPC Basics, which is a fundamental concept in AWS networking. Understanding VPC is very important for both real-world projects and interviews. What is Amazon VPC? Amazon VPC stands for Virtual Private Cloud. It is a logically isolated network in AWS where we can launch our resources like EC2 instances. It works similar to a traditional data center network, but in the cloud. We get full control over IP addressing, routing, and security. Why use VPC? We use VPC mainly for security and control. It allows us to isolate our resources, define our own IP address range, and control traffic using routing and firewall rules. It also enables connectivity with on-premises systems using VPN or Direct Connect. Key components of VPC. A VPC consists of several important components. VPC itself, which is the network. Subnets to divide the network. Route tables for traffic routing. Internet gateway for internet access. NAT gateway for private subnet internet access. Security groups and network ACLs for security. These components together form the complete network architecture. VPC CIDR block. CIDR block defines the IP address range of the VPC. For example, 10.0.0.0/16 gives around 65,000 IP addresses. Proper CIDR planning is very important because it affects subnet design and future scalability. Subnets. Subnets are subdivisions of a VPC. There are two types. Public subnets, which have internet access. Private subnets, which do not have direct internet access. Subnets are usually created across multiple availability zones to ensure high availability. Internet gateway. Internet gateway is a component that allows communication between the VPC and the internet. It is attached to the VPC and used in route tables to enable internet access for public subnets. Security groups. Security groups act as a virtual firewall at the instance level. They control inbound and outbound traffic and are stateful, meaning return traffic is automatically allowed. Network ACLs. Network ACLs are another layer of security at the subnet level. Unlike security groups, they are stateless, so we must explicitly allow both inbound and outbound traffic. Route tables. Route tables determine how traffic flows within the VPC. For example, if we add a route like 0.0.0.0/0 pointing to an internet gateway, it allows internet access. NAT gateway. NAT gateway is used when instances in a private subnet need internet access. It allows outbound internet traffic but blocks inbound traffic, improving security. VPC architecture example. In a typical architecture, public subnet contains web servers. Private subnet contains databases. Internet gateway is used for public access, while NAT gateway is used for private subnet internet access. VPC connectivity options. There are multiple ways to connect VPCs. VPC peering for VPC to VPC connection. VPN for secure communication with on-premises. Direct Connect for dedicated private connection. Transit Gateway for large-scale networking. Best practices. Some best practices include: use private subnets for sensitive resources like databases. Restrict access using security groups. Use NAT gateway instead of exposing private instances. Plan CIDR blocks carefully. Enable VPC flow logs for monitoring. Real-world use case. A common real-world architecture is a three-tier application. Web layer in public subnet. Application layer in private subnet. Database layer in private subnet. This ensures security, scalability, and high availability. Summary. To summarize, VPC is the foundation of AWS networking. It provides isolation, control, and security. Understanding its components is essential for designing cloud architectures. Thanks for watching. Like, share, and subscribe for more AWS tutorials. Turn on notifications to never miss updates.